Bear with me, please, because I've made this video twice now and it got eaten by my computer, so hopefully this time it's all going to work out. Okay, so I wanted to kind of go back and remind you what I said at the beginning of this section, which is that the domain, there it is all the possible values of the independent variable, which is sort of like your x, right? And I wrote that right here, every possible x. And then the range is all the possible y values, all right? So when we get down to here, what we're supposed to be doing is finding, there it is, the value of the domain in the range. Now domain, every possible input x would means you're going to be going from left to right. You want to start with your farthest left value and then go to your farthest right value. Your range goes down to up. So the lowest you go to the highest you go. All right, now again, I already did this several times, so please bear with me, but the domain, the farthest left this graph gets is -8. And then the farthest right it gets is +3. And you got to use the x numbers because x is the measurement of left and right. So domain will be the -8 and the +3, the x values. Now the range, the lowest the graph ever gets to is -4. So a lot of students usually see -4 is lowest, great. But they make the mistake of trying to pick the 2 up for the positive high number. But this graph gets higher than that too. Right? This whole region in here, this little hill right here, it's higher than 2. So you want to pick 4. 4 is the highest this graph ever reaches. Now you notice that when I did this, I did it with less than or equal to. That's because I actually got to those spots and had closed dots. If I had open dots, then that would be just a plain less than. But since I'm less than or equal to, it means I actually get to those numbers. Like I get to 3, that's why I'm less than or equal to 3. It's got a closed dot. All right. I want to sketch the graph of a function whose domain is -2 is less than or equal to x, which is less than 5, and whose range is -4 is less than y, which is less than or equal to 2. The issue here is that this is a great question to ask, but it's difficult because there's no one right answer. There's a lot of correct answers for this. Tons of them, in fact. So take a moment and think about that, right? There's got to be tons of functions that would do this. Now it's got to be a function, so I'm going to have to make sure it passes the vertical line test when I'm done. And I put a dot down here. Now what am I doing? Well, it's -2 is less than or equal to. That means I get a closed dot on the -2 side. So I put -2 right here. Now I could have picked it there. I could have put it at 0, like that. In fact, I could put it pretty much anywhere along this -2 line, as long as I don't get out of the range. So the lowest I could get to is -4, but I can't actually reach that because it says -4 is less than y. I can't actually get down to that spot. But I could do like -3.8, like that. So -3.9 would be okay, -3.99, but I can't go to 4 because 4 is less than. I could have that dot go anywhere along here up to 2, but I can't go any higher than 2 because the range only gets to 2. So I can't go up here to the 3 or the 4 region. So what I'm saying is put your point wherever you want. So you just put your pencil down on the paper somewhere between, so put it on the -2 line, the vertical line, -2, but somewhere between -4 and 2. Any place is fine. I'm going to do it at -3. Just for the heck of it. No good reason, just because I feel like it. All right, now you're going to be making a line or a curve or something that kind of flips around and does what you need it to do, but you need it to end up over here on the high side at 5, because the x value goes all the way to 5. So I'm going to get up over here on the 5 side, but I can't actually quite get to 5. I can get close to it, but I can't quite reach it. So let me draw that like that, where there's an open circle because it says it's less than 5, not less than or equal to 5, but less than 5. So I have to do kind of an open dot thing. All I need is some kind of curve or line that connects these points. And again, it didn't have to be this point. Let's see if I can draw this with the draw feature. Let me get this in here. All right, so I'm going to start here. I'm going to go down and then Let's see if I can go up. Why not? Oopsie, that didn't work. Something like that. So you're kind of looping around. And of course, this wasn't the only way I could have done this. This was just the one I came up with. I could make a different one. Heck, I could make a line. I mean, that'd be kind of boring, but you could do it. You could start over here at this dot, end over here at that dot. That works. And it doesn't quite achieve what we want, though. I guess it doesn't work. I take it back. Because we don't get down to the -4, right? And we don't get up to the, what is it? +2. Oh, no. It's down to -4, up to 2, and back down. Right? We could do something like that. Just kind of, we would need an open dot down here. I like this better. There, so you need an open dot down there because you can't actually reach -4, and you can't go any lower than -4. That would be no good. And then you go up. You got to get to 2 because we have to get that high. So let me put a little dot up there so that way this is valid. There we go. That works. It's nice, actually. It's nice drawing it by hand. So I just kind of connected things up with lines and saw what happened, right? That's totally valid. Oops, sorry, I'm having issues with my graphing program here, or my drawing program. There we go. And again, there was nothing magic about the points I picked. It's just that they had to be between -2. Okay, so over here I had to start at -2. Had to, because it says -2 is less than or equal to x. But it could be here or here, anywhere on this line, as long as it's not higher than 2 or lower than -4. So I just put it right there. Now I have to get down to -4, but I have to have an open dot down there because I'm not allowed to actually have -4 as a number. So I had to give myself an open dot. And then I had to make it go all the way up to 2 somehow because I have to get to my range value of 2. So I have to go -4 to 2. Can't reach -4, open dot. Can reach 2, close dot. -2 over here on the x, I get to, but over here on the 5, I need an open dot because it's less than. You can make these curves, you can make them lines, all of that is a-okay. But you've got to get down to as low as these values get and as high as they get, and as far left and as far right. Notice everywhere there was a less than, I reached it, but with an open dot. So like over here at the 5, open dot because that's less than. Down here at the -4, open dot because that's less than. Over here at the -2, close dot because that was equal to, less than or equal to. Over here, I reached that one, that was a +2, that's why it gets a less than or equal to 2. And always double check yourself when you're done. Does your graph fit in the window? -4 to 2 for your y values. So low is -4, high is 2, left is -2, high or far right is 5. If you fit into those two windows, then you've done your good job. Oh, and make sure it's a function. Make sure it passes the vertical line test, which this does. And again, there were lots of answers for this. Tons and tons and tons and tons of them. You didn't have to start at any of the spots that I picked. You didn't have to end the spots that I picked. You just have to make sure that your graph fits into the window that they give you. As a matter of fact, this gives me a totally different idea. Just a different way to do this whole thing. So let me draw this for you. So can you see the blue lines that I drew? They're not really part of the graph, but I just wanted you to see. So it said -2, so I put a solid line on -2. Just the portion that I need, though, from -4 to 2. Then I did 5, that's over here. X equals 5, but that's dotted because it says less than. Then I have the -4 down here, dotted, and the +2 solid. Your graph has to fit in that square. Any curve that you can get that would fit in that square and would hit all 4 edges of the square, that would work. Anytime you hit the dotted lines, you're going to have to do an open circle. Anytime you hit the solid lines, you're going to need a closed circle. Right? These two coordinate things are totally giving you a box in which you have to fill your graph. And it's got to be like a billiard table. You got to bounce off of all 4 edges. I've hit this blue edge, hit this blue edge, hit this dotted blue edge, hit this dotted blue edge. You've got to make sure your pool balls, your billiard balls, have hit all 4 edges. Anytime it hits the dotted ones, you get open dots. Anytime you hit the other ones, you get closed dots. That's it in a nutshell. And that's probably a good way to attack this problem in future. Start by making these 2 things into boxes, right, with solid lines and closed and dotted lines, just kind of hypothetical, and then make the curve fit inside that box and bounce off of all sides like a pool table. All right, we're all done with chapter 1. I will meet you back here maybe for chapter 2. See ya.